Right, we've got in a hub motor. The cable is smushed, of course. Why wouldn't it be? We've got our replacement cable here. We use extension cables because it makes life way easier. Then if you ever need this end, you've got this end, and if you need this end, you have this end. So this is what was on there, one of these. And we're going to make it, I think, to about the length of the wheel sticking out. So we'll snip the end of this at some point. Give it a go. First of all, we've got to get into this motor, which involves 1, 2, 3, 4, 5, 6, 7, 8 Allen heads. They are, I believe they're that size. They are, which is a 4mm Allen. You can't see, but it's a 4mm Allen. I'm not lying. Those. Shall we get ourselves a tray? Let's do that. Put them in there. Right, to get the side cover off, well, we're going to reuse this spring probably, I think, because it's handy. To get the side cover off, we need to tap the axle from that side. Now, we probably want to put a bolt on that, otherwise we'll round over the end of the axle, which will not be good for anybody. I think it's not that size. That's more like it. That's the one. I think it's a 14mm nut on those. Let's take our world's biggest hammer. We'll give it a little tap. Got a little gap in there now. There you go, side cover's spinning at least. It's a bit of a start. We're just going to have to try and lever this one off. Hey! Ta-da! Side cover off. There's a couple little scratches on the edge, but nothing too major. Here are the windings I was on about. They're what you don't want to be smushing with whatever tool you're using to open it. So if you stick a screwdriver in too far, up to here, and you start prying on here, you're going to ruin the windings. Not what you want to do, obviously. Luckily, cable's on this side, which is nice. So we did, in fact, open the correct side. So, we want to snip that cable tie there. Going to hold those in. Bit of rub through there, but nothing too major, I don't think. To get the cable out of the axle then, what I find easiest is just to snip it at the base of the axle here. Like that. Then we know where all our colours go still, nothing's confusing. So our Hall sensor wires, those are our motor cable wires, gives us something to join onto, no problem. And then we can work on getting this out. Find long nose pliers, get on there, lever against the axle, tends to start getting it out. It's never fun, always a pain. There's there's a load of silicone inside that likes to make life difficult, and the outer cable housing sticks to it, and I never quite found a good way of getting it out. Maybe I'll try a little flathead screwdriver just to kind of cut that silicone bond so the whole thing will come out as one. There's quite a lot of access in this motor, which is nice. Well, that looks promising. That's nice. Oh, look. Out as one. Just about one. That's good, you never get that. So now we can see off that goes. Clear down the axle hole. You probably can't. Oh yeah, you can. You can see down in there. There's light blocking off the light. Clear, which is great. Get a bit of lube, spray it down in there, make it nice and easy to push the new cable through. Now, does the cable fit through the side cover of the motor? Sometimes the hole, like in the Bafang motors, it doesn't fit through. It does in this one, so that's great. We don't have to leave it on right now. If it doesn't, and this end doesn't fit through there, or let's say you've got this cable on there, I know this is just a seal, but ideally we don't even want to disturb it. Sometimes you just can't get it through. Therefore, when you cut the end off, you've got to make sure you put it through and do all your work with the side cover dangling off the cable. Otherwise, you'll finish it all together, go to put the side cover on and go, ah, shit. So, not what we want to do. Now, our customer wanted us to go to about the edge of the wheel. So about there. So I'll take this one to there. Inside the motor. Probably going to cut him about there. We can use this as a breakout cable or something in the future if we ever need to. Better to have too much cable than not enough. If you bend the cable into a slight hook first, it makes it much easier because it's going that way, round through there. Getting hung up on something. Okay, let's push past it. Oh wow, we're in. Wow, that was easy. It's never that easy, ever. So look at that. Right, if you pull a reasonable amount through, it gives you loads of room to work with. You're not trying to work with like an inch of cable. Then you can open up the sheathing. Bit like that. Pull a good and reasonable quantity of that out. Cut that off, and then we can be joining it all up. It's quite handy to have a lot of slack in there because you can always just pull it back when you're done with it. I will reseal that, but I'll do it at the end. I'll do some testing and stuff off camera because that's not exciting. Before I reassemble the motor. So. Now sometimes if you've had a damaged cable, it means the hall sensors are blown. Hall sensors are on the other side of this motor, so we would have to pop the other side cover off, which is annoying. But anyway, if we have to, we have to. I will be testing this, the motor plug. I'll test the hall sensors once it's all finished up and put back together. Again, do it off camera, but don't just rewire it thinking, oh, it'll be good to go. Check the sensors, because while you've got it apart, you might as well take the other side off, replace the sensors if they need doing. If they don't, just don't disturb them. Easier. You can join wires a variety of ways. You can twist them. You can do that thing where you push all the strands in together like that and squeeze them down and then wrap them in tape or heat shrink. This is the method we're going to use, where we just squeeze the strands together, I think. Probably going to go with that. Who knows? We might not actually. We might just go with it like that, joined side by side. Don't know what power this motor's rated for. Sometimes it tells you on the side cover. Sometimes it doesn't. Doesn't on this one, but looking at it, it's like a 48 volt, 1000 watt motor. Windings are nice and shiny as well, which is good. Because joining it like this isn't quite as strong of a solder join as this, where you push the strands in together, but then you end up with all these stupid spiky bits coming off it. It's not that much fun. Should be alright. Apply flux. Always helps. I know that you can get flux called solder, but applying a bit of flux just makes life easier. Soldering iron, solder, exactly what you'd expect to do. Not about to try and teach people how to solder, because there's a million videos of that already. Probably a million videos of this already. But you just make sure it's coated all the way around nicely, on the bottom, on the top. If you had too much solder, it would drip out off the bottom. Be really annoying. Have to clean it up. It's joined. Go ahead and we can do the same for the green cable. Apply flux, apply solder, get any of those little stray cables there, we can just snip them off before we go to insulate it. Not the end of the world. And then we want to do the same for our blue cable. Hopefully you know the drill by now. So, flux solder. Make sure it wicks all the way in. They can be insulated once they're cooled off because they're going to burn me. Otherwise, cables. Just want to get good. So they're all done. Twist ends if they're all splayed. Flux on those and solder. Okay, they've cooled off a bit. I'm going to trim up the sticky outy bits on here because they're just going to pierce the insulation, and there was no point doing the job at all because the customer will still have a knackered motor. You just want to do it so there's no really sharp edges. Insulating tape, high temperature stuff, also great. Wrap it. That's that, and then we're going to do exactly the same thing for the hall sensor cables where we join them up. Or snip straight through them. It's all a good option really. God, that one was being annoying. And there's that one. So we're going to do the same thing where these aren't all splayed, which is nice. Apply solder and flux. Like that. These ones we are wrong draw. Going to heat shrink. So it's just better. cables, 3 lengths of heat shrink. Cut them in half, 6 lengths of heat shrink. Maths. Make sure you put the heat shrink on first, because you'll have a bad day if you don't. If you don't have heat shrink, you could still use insulating tape for that. The reason I don't, or didn't heat shrink these, the phase wires, is because they get so hot when you solder them that the cable lengths aren't that long. The heat creeps up the wire and then shrinks the heat shrink before you want it shrunk, and then you can't get it over the connection anyway, which is really annoying. So, we're just going to get these lined up nicely. Again, I'm not here teaching people how to solder, just what needs to be done in this. There's our white one, and you can then slide the heat shrink over, just like that. You can use a lighter heat gun, just about anything to do this. This has got to be hot. It's called heat shrink, not burn shrink. Don't set it on fire, just it shrinks when you know when it's shrunk, 'cause you can't move it anymore. It'll stop visually moving. If the wires aren't lined up really straight, the solder won't work, or the heat shrink won't work, solder will work. If you want, you can pull on the cable, make sure you've got a good bond. Doesn't quite want to go past itself, so I'm just going to snip the corner of that cable off, just so it's got, there you go, slide straight over now. This lighter is terrible and useless all at the same time. There's our red one. You probably can't see anything I'm doing right now because my arm's in the way, just realised, but just soldering the cables together, nothing exciting. There's another one where there's a little bit of a sticky out corner on here, so the heat shrink won't slide over it. You can just snip that off to make it go smoothly over, like that. Where's the terrible lighter gone? There. Normally I use a heat gun to do this, but it's super loud, don't go shh. And then when it runs down, it's again very loud, so I just thought I'll do it this way, and then at least you can hear the things I'm saying. Not that they're very interesting. I can already tell the heat shrink's not going to go over this one. There's our black one. Two more. Blue hole next. Oh, I didn't like it. there's no solder on my soldering iron. No wonder it's not working. You normally need just a tiny bit. There you go. Solder. And our yellow cable. That's the last one. Let's just put a bit of flux on this, make it easier. Should all flow then. And there's that. What this will need doing is you've got to cable tie these back up where they were, so they're all, you know, against the stator. Otherwise, when the motor spins around, it's just going to flap about and do terrible, terrible things. Motor tester, you need to plug into that. So you need like a breakout cable, which you could, I suppose, make with the other end of this that you chopped off, because then that would connect to that. Line up the arrows, can't see the arrows, line up the arrows and all that. I have one already, it looks like this. Got these on the end, so bullet connectors, and one of those which connects to these super fun motor testers. Put that on there. So they don't all line up like that, so when there's a baffang one, they line up slightly out, so the arrows don't actually match. It's a whole thing. There you go, that one's 8 fun, so baffang, this one's Dulet. The replacement cable that we used. So I will tell the customer about that this may not match. The pin out's the same, but the arrows don't actually line up. Who knows why? They just, I don't think there's many standards to these things. Hall sensor plug goes to hall sensor plug. And you can test the phases if you can spin the motor around really fast, which you can't right now, but that's not a problem. So to test the halls, turn it on. See the yellow hall is active. They want to flash up, so 1, 2, 3, 1, 2, 3. Oh well, they kind of go round in a circle. The only real way to spin this at the moment. What is that? No idea what that is. The only way to spin this at the moment is going to be with a spanner. Because we can't spin it very fast or far because the magnets are touching, because the bearing's not on the side plate, can only do it fairly slowly, gently. Bigger spanner, more leverage, easier. Hold the rim. There you go. We saw blue, green, yellow all flash up. And if we go back the other way, like that. I'm not going to do it too much like this because it's just going to scrape the magnets. With the side cover on, obviously the motor will spin nice and smoothly. That's pretty much it. You want to get these cables put back in, cable tied back into place. You can have more insulation if you want. I might put a bit of this around it. I've got some of this spare. Silicone up the hole so that water tries not to get in as much. Side cover back on, make sure everything's lined up. Nothing's touching the side cover. You want to give it a spin, make sure you can't hear any of these touching the side cover because it will wear through the cable and it shorts out to the case. It's all a whole thing. The side covers on these weren't sealed anyway, so it's not going to get resealed. I doubt the other one is. I don't think this has been off. And then, of course, test the hall sensors, test the phase wires, or if you can't do that and you don't have that, put it in the bike, check it. That's it. Thanks for watching.